Okay, so the paper we have at hand is February March 2023, last year's February March paper, and time for which is 1 hour 15 minutes. This is the theory extended version. So let's start. The first question is about it's a question from the atmosphere chapter, the environment, and it's a pretty straightforward question. You just have to remember the theory for answering this. The pollutants, this is from pollutants. We have pollutants: carbon monoxide, carbon dioxide, oxides of nitrogen, and oxides of sulfur. You have to remember the effects of these, from where and how are these produced, and how the effects created by these pollutants can be minimized. So the first one is, name one gas found in clean dry air which contributes to global warming. Now we know which is this gas. It is carbon dioxide. We can write the formula or the full name: carbon dioxide, which contributes to global warming. Next is also pure theory. You just have to remember this. The percentage of nitrogen in clean dry air is 78%. Name the substance used to remove sulfur dioxide in flue gas desulfurization. Now what is this? When we burn fossil fuels, the fossil fuels, coal for example, contains sulfur. So when we burn it and it reacts with oxygen in a combustion reaction, sulfur dioxide and sulfur trioxide are produced. To minimize that, to reduce the sulfur dioxide, we have flue gas desulfurization. Desulfurization, it is self-explanatory. Desulfur meaning to remove sulfur. Now we use what? Calcium oxide. It is a solid substance we use while burning the fossil fuels in the chimneys, so that the fumes released are pure, are desulfurized. There is no sulfur in them, because sulfur, what is the harmful effect of sulfur? It causes acid rain. Same is for nitrogen. Next, nitrogen dioxide is formed in car engines. Name the equipment in a car exhaust used to remove the nitrogen dioxide formed in car engines. Now we know what is this: catalytic converters. Pretty straightforward. Next question. All gases diffuse. Choose from the list of formulae the gas which diffuses most quickly. So this is a frequently occurring question. You just have to remember that diffusion depends on the MR, molecular mass of any compound. In this case, gases. Mostly you have the question related to gas. Like this, they will give you random gases and they will ask which diffuses most quickly. So it is common sense. Gas having the lowest molecular mass, the lowest mass, will be the fastest to travel, because what is diffusion? Diffusion is the spreading away of particles from an area of higher concentration to lower concentration. So the gas which is lighter, it is obvious that it will move the quickest. So we just have to calculate the MR of all the gases and then circle the one which has the lowest MR. So CO means 12 plus 16, which is 28. CO2, we know this is we don't even need to calculate, because we already know if this is CO, this has 2 oxygens, so this will be having a higher molecular mass than CO, so we reject this straight away. Now CH4, 12 plus 4, 16. NO2, 14 plus 16 times 2, which is 46. Sulfur dioxide, same. Sulfur has 30, around 30 I guess, 32 or 31. You can check in the periodic table, but 31 plus 32, it will be higher than all of these. So what we have is methane, CH4, having the lowest MR. Now you can explain, which I just told you, that CH4 has the lowest molecular mass. Simple. You can take this with an example. The person who weighs the lightest is more likely to run faster than a person who weighs higher. A 50 kg person can run faster than a person weighing 80 kg, an obese person. Now, one adverse effect of carbon monoxide on human health. Carbon monoxide is poisonous for humans. Poisonous, or you can write toxic. The carbon monoxide reacts with hemoglobin in the blood. Hemoglobin in the blood to form carboxyhemoglobin. So oxygen can no longer combine and leads to death. Carbon dioxide is a reactant in photosynthesis. Name the two products of photosynthesis. We know what the equation is. CO2 plus glucose, which is C6H12O6, equals to 6O2 plus 6H2O. Sorry. The products are oxygen and water. Water and oxygen. Sorry. My mistake. It is 6H2O producing 6O2 plus C6H12O6. We don't even have to write the balanced version. We just have to remember the products over here. So what are the products? Glucose and oxygen. Really sorry. Next, we have to complete the dot and cross diagram in a molecule of carbon dioxide. Show outer shell electrons only. So carbon has 4 electrons in its valence shell, in its outer shell, and oxygen has 6 electrons. So oxygen needs 2 electrons to complete its outer shell, and each oxygen needs 2 electrons, and each carbon gives 2 electrons. In this case, it is better to write shares. It shares 2 electrons. So we have 2 oxygens and 1 carbon. Each carbon shares 2 with each oxygen, 2 electrons, and each oxygen makes a double bond with each carbon. Double bond meaning CO double bond, CO double bond. 2 electrons like this and 2 electrons like this. Straightforward. Now, one thing for which you have a mark 2 is the lone pair electrons. Oxygen has a total of 6 electrons in its outer shell. It has only shared 2. So how many will remain? 4. Oxygen will have 4 electrons remaining. We use cross for oxygen and dot for carbon. So remember to make all the lone pair electrons of each oxygen atom. Next, first question complete, 11 marks. The paper starts off with a pretty simple question. Now, lithium, sodium and potassium are group 1 elements. Name the type of bonding in these elements. We know these are all metals, group 1 till 3. So metallic bonding exists in metals. We have 3 types of bonding: covalent, metallic and ionic. In ionic compounds, in which there is a cation, or better to say there is a metal and a non-metal. Covalent, in which electrons are being shared, and metallic, in metals only. Not in any metal there is metallic bonding, in which there is a delocalized electron, sea of delocalized electrons, and a metal cation. You can also have a diagram asking you to draw the metallic bonding, to show the metallic bonding, in which you will draw the cations and the electrons. Well, this is not the topic of discussion over here. Next, sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. State the test for hydrogen gas. Pure theory. We have a lighted splint test. You will find this in the notes for qualitative analysis. Notes for qualitative analysis in your syllabus. you have tests for various gases: carbon dioxide, hydrogen, oxygen, ammonia, and you have to remember all of them. Here they have already only asked for hydrogen, and you will find all of them in your notes for qualitative analysis. Now, positive result, the splint will pop sound produced. Suggest the pH of a solution of a strong alkali. Now we know 0 till 6 is an acid, and 8 till 14 is an alkali, with 7 being neutral. Now from 8 till 14, the alkaline nature, the pH increases, and the solution, the alkali becomes stronger. Similarly, in acid, 1 till 3 is a strong acid. Beyond that, as you near 7, you have a weaker alkali and a weaker acid. So the strong alkali will have a pH of, we can write, approximately 12. Name the substance which can be used to confirm the pH of a solution of a strong alkali. Now, if they were asking simply to identify a strong alkali, we could have just used litmus paper, because the litmus turns blue in an alkali. But here they have asked us how to confirm the pH. For the pH, we want exact measurement or an estimate of the pH variation, for which we can only use universal indicator, which will give us a color change based on the color chart, which will explain to us how strong an alkali is. So write the symbol equation for the reaction between sodium and cold water. So this is a 3-mark question. There will be a separate mark for the state symbols: aqueous, solid, gas, liquid. And my number 1 tip to you is read the question carefully, because you might miss the state symbol thing. Now sodium reacts with what? Cold water, producing NaOH, sodium hydroxide, plus hydrogen gas. Hydrogen gas is diatomic, so we write 2. The H and OH ions in the water, H plus and OH minus, reacts with Na as it is positive. You just need to remember the equation. Now the state symbols are: sodium is a metal, you know metal are solids, water is a liquid, NaOH is aqueous, alkali, OH, NaOH is aqueous, meaning it is soluble in water, and H2 is a gas. Now for the balancing, we have 3 hydrogens over here. Now my tip for you is to try and make even numbers when you are balancing. For example, here you have 3 hydrogen, make it 4 hydrogens. 2 here, 2 here. 4 hydrogens. Here you have 2 hydrogens, so we can make this 2. We can write this 2 to make total of 4 hydrogens. Now 2 oxygens, 2 oxygens, 2 oxygens, 2 oxygens. Oxygens are balanced. Hydrogen, 2 2s are 4, 2 and 2, 4, balanced. What remains is Na, and we can write just 2 over here to balance the Na. Lithium has 2 naturally occurring types of atoms, Li6 and Li7. State the name given to atoms of the same element with different nucleon numbers. Nucleon numbers is the mass number, which is the sum of the number of protons and number of neutrons. So this is an isotope. They can also ask you the direct definition of isotopes, which are atoms having same proton numbers. For a 2-mark question, atoms having same proton numbers, same number of protons, but different number of neutrons. Also, they can go on and ask you why the chemical properties of isotopes are similar. Why are the chemical properties not different? So the answer for that is they have the same number of protons and electrons. Next, we just have to write the number of protons in Li6. Now you have the periodic table with you. You can see in it Number of protons, lithium is in group 1 and it has total of 3 protons. I might as well show you the periodic table. Here you can see lithium has 3 protons, because as I said, it is an isotope of lithium. So the lithium given in the periodic table will have the same number of protons as either of them, but the number of neutrons can be different. So number of protons will be the same for each of them, 3 and 3. Number of neutrons will be the mass or the nucleon minus the number of protons, or the proton number simply. So 6 minus 3 will be 3, 7 minus 3 will be 4. Now for number of electrons in a neutral atom having no charge, having no net charge, it will have always the number of protons same as the number of electrons in a neutral atom. So 3, 3, 3. For an ion, however, you have to look at this carefully. It is an ion. An ion means it has a charge. Here we have a plus charge, meaning that it has a positive charge, meaning it has more protons, as protons have positive charge, and electrons have negative charge. So in an atom, when there are equal number of protons and equal number of electrons, they cancel out each other. 3 protons means 3 pluses, and 3 electrons means 3 negatives. 3 minus 3, 0. No net charge. But when there is a charge, so there will be the same number of protons. The proton number never increases, mind you. The number of protons remains always the same. However, the electrons are transferred while reacting. So here we have a plus, indicating that there is one fewer electron than number of protons. Let me be more clear. The number of protons are 3. So in order to get a plus charge, we have to have, with 3 protons, we have to have 2 electrons, giving us a net positive charge. Had this been minus, then we would have one more electron than total number of protons. The total number of protons is 3. One more electron will give us 4 electrons. But here we have positive, so 1 electron less than total number of protons, which will be 2. Now there is a standard question giving you the relative abundance. Table 2.2 shows the relative abundance of the 2 naturally occurring atoms of lithium. Atom abundance 10%, 90%. What this means is that the lithium having a mass of 6 and lithium having a mass of 7 is present 90% in the naturally occurring atmosphere in the environment, and 10% is the percentage in which lithium exists, having 6 nucleon number. This is the reason the major isotope is included in the periodic table. Or it is better to say that this is we have to calculate the atomic mass. This is just the abundance, and this is the isotopic mass given. So the formula for relative atomic mass AR equals to the percentage abundance multiplied by mass of one isotope, adding all the isotopes. The same way, if there was one another Li8 and this was maybe 80% and this was another 10%, what would we do? We would do this thrice. Now as it is percentage, we know percentage means to divide it by 100. So what should we do? 10 over 100, or we can simply write 0.1 times the mass is 6 plus 0.9 times the mass is 7. They can change and switch and shuffle the question a little bit by giving you the relative atomic mass and maybe asking you for the relative abundance of this. In any formula throughout chemistry, they can shuffle the values whenever they want. They can hide this from you and give this to you in all formula. So when we multiply, this will give us 0.6 plus 6.3, which is 6.9, and as they said, to one decimal place, 6.9. The mass of one atom of lithium compared to 1/12 the mass of a carbon 12 atom, because relative means it is depending on something, it is relative to something, compared to something. And what is it compared to? The 1/12 of the mass of a carbon 12 atom, meaning the carbon having mass of 12. Next, potassium oxide K2O is an ionic compound. Complete figure 2.1 to show the electronic configurations of the ions in potassium oxide. Show the charges on the ions. So we have to complete first of all the electronic configurations, meaning we will have to draw the electrons. Second, we have to show the charges. This is a potassium atom, this is a potassium ion, as it will have a charge. Now potassium is in group 1, meaning that it will donate one electron. Group 1 meaning it has one electron in its outer shell. Originally this was this, having one extra electron over here. When it loses this electron, it loses this shell. This shell is gone, giving it a complete octet. So meaning it will give one electron away, having a plus charge, like when we did in lithium. So each potassium gives one electron, and each potassium has a charge of plus 1. We don't need to write the 1, so plus. Now for oxygen, group 6, 2 minus charge, 2 electrons needed for each atom of oxygen to become a stable oxygen ion, oxide ion, like we did in the carbon dioxide dot and cross. So the charge will be 2 minus, as it is in group 6, having total of 6 electrons in its outer shell, requiring only 2 to complete the 8. It only has 2 shells. The second shell will have donated 2 electrons from each potassium ion. Each potassium gives 1 electron to the oxygen. So oxygen originally has 6 electrons, 1, 2, 3, 4, 5, 6. So the 6 of original oxygen will be drawn with a cross, and the 2 given by the potassium will be noted by a dot. So total oxygen has 8 electrons originally. An oxygen atom has 8 electrons and 6 electrons outer shell. So 1, 2, 3, 4, 5, 6 in its outer shell, and 2 from each potassium, 1, 1. Next question. The Haber process is used to manufacture ammonia. State the main source of each gas used in the Haber process. You just simply have to remember this. Fractional distillation of air. When liquid air is distillated fractionally, it gives us nitrogen, and hydrogen is given us we get hydrogen from methane. When we burn natural gas with steam, we get methane. You just have to remember the sources, no need to remember the details. The equation for the Haber process is shown. The reaction is reversible. The forward reaction is exothermic. By the way, you should be remembering this equation, and you should know how the NH3 forms. The relevant factors of which are affecting the equilibrium, as it is a reversible reaction, indicated by this double arrow. State what is meant by the symbol AH. This is the enthalpy change, the energy change in the reaction. When it is negative, it is exothermic. When it is positive, it is an endothermic reaction, meaning it absorbs more energy than it releases. And exo means it releases more energy than it is absorbing, and the surrounding temperature of the reaction mixture will increase in this case as it releases heat, and in this case the surrounding temperature will decrease. Now the enthalpy change for the forward reaction is -92, also told over here. State why this value shows that the forward reaction is exothermic. Because the enthalpy change is negative. Enthalpy change is negative, and enthalpy change basically means energy in minus energy out, energy over here minus the energy over here. So when the energy released over here by the bond formation is more than the energy needed here for bond breaking, then the reaction is exothermic. State the typical conditions and name the catalyst used in the Haber process. Now the typical conditions we know: 450 degrees Celsius, 450 degrees Celsius, pressure is 20,000. Normally we write 200 atmospheric unit, and this is 20,000 kPa. Catalyst we know iron, which is a transition element or metal. Complete 3.1 to show the effect, if any, when the typical conditions in the Haber process are changed. Use only the word increases, decreases, or no change. So looking at the equilibrium, where the equilibrium shifts, we can deduce the concentration of ammonia, as ammonia is over here. If the equilibrium shifts towards right, ammonia increases obviously, and vice versa. So what are they saying? They're saying the temperature when increased, what will be the effect on the rate of forward reaction? Obviously the rate increases when the temperature increases. Next, effect on the concentration of NH3 at equilibrium. So when there is an exothermic reaction and we increase the temperature, the equilibrium shift towards left, the reaction goes backward. This is what you have to memorize, and you can get 2-4 marks standard questions regarding this, that when the temperature is increased, where the equilibrium moves, why does this happen, explain. 2 marks for this, 2 marks for the pressure one. Here however they have only asked about the concentration of NH3 and not the reason. So when the temperature is increases, the concentration decreases, only decreases. We have to write only decreases. Why? Because the equilibrium shifts towards the left. When the pressure decreases, now when referring to the pressure changes with respect to the change in equilibrium, we have to see the number of gas moles on either side of the equilibrium. Here you have 1 mole of nitrogen and 3 moles of hydrogen, totaling of 4 total moles. Here you have 2 moles of gas. Now when pressure is increased, the reaction moves from higher moles, or you can simply write the side with fewer moles of gas is necessary to mention, is favored. I hope you can see this. Here you just have to write increase or decrease. That's why I'm not writing it properly. When the pressure is increased, the equilibrium, the side with fewer gas moles is favored, meaning that the side having fewer gas moles, the equilibrium will shift to that side when pressure is increased. However, when pressure is decreased, in this case when the pressure is decreased, what will happen to the equilibrium mixture? The equilibrium will move to the side with higher gas moles, which is on the left hand side. So the concentration of ammonia is bound to decreases. And the effect on the rate of forward reaction: when the pressure decreases, there is no effect on the rate of reaction. So considering the pressure change in the case of the effect of the rate of forward reaction, when the pressure decreases, the rate will also decrease, as there will be fewer molecules of gas, particles of gas closer to each other, so there will be fewer collisions. So the rate will decrease. As for catalysts, there will be an effect on the rate of forward reaction, as catalyst only affects the rate of reaction. The catalyst does not affect equilibrium mixture or the position of the equilibrium. So there will be no change over here. Now the standard question regarding the rate of reaction: explain in terms of collision theory why increasing the temperature increases the rate of the reaction. So what happens is, the rate of a reaction depends on the number of collisions between the particles. So using common sense, using proper science, when temperature is increased, we know that the kinetic energy of the particles increases. What happens when the kinetic energy of a molecule, of a particle, of a substance increases? It moves faster, because kinetic energy is directly proportional to the velocity squared. Meaning, when kinetic energy increases, velocity of a molecule of something increases. The speed of the particles increases, and there are more collisions, more effective, better to write, effective collisions between the particles. And one more thing is that more or higher proportion of particles have energy above the activation energy. Now what does this mean? The activation energy is the minimum energy required for particles to start to collide, to have effective collisions in between. Meaning, the activation energy is the energy when minimum energy when it is supplied, the reaction starts. So common sense, when more particles have energy above the activation energy, so more particles can collide, and we know that when there are more collisions, the rate is faster. So because we increase the temperature, thereby providing heat energy to the particles, increasing their energy, the energy of the particles. Now if there is a dedicated activation energy for a reaction to commence, and we increase the energy provided to the particles, these are the particles, their energy is increased by us, and more particles reach this threshold amount beyond which they can react. Now what happens when we don't increase the temperature is that fewer particles reach this threshold amount. Now ammonia reacts with an acid to form ammonium sulfate. State the formula of the acid used. Now we know every acid has H in it: HNO3, H2SO4, HCl. Next thing we can see over here, there is a sulfate. Which acid contains sulfate? Sulfuric acid, H2SO4. Had this been NH4NO3, we would have chosen in our answer HNO3, because nitrate. State 1, use of ammonium sulfate. The fertilizers are the primary use of ammonium compounds. Calculate the percentage composition by mass of nitrogen in NH4,2SO4 ammonium sulfate. Now how do we calculate the percentage composition by mass? This is the mass of the desired element, or in this case the mass of nitrogen, over the MR, meaning the total mass of the compound, molecular mass, multiply by 100. We have 2 nitrogens over here, so this will be 28. 14 plus 14, 28. And the MR will be, if we look at the periodic table for sulfur, sulfur has a mass of 32. So 28 for the N2 plus 8 for the hydrogen, as there are 4 and 2, 4 2s are 8 hydrogens with 1 mass each, plus sulfur has a mass of 32, plus 16 times 4. Multiply by 100. You can simply put in this in your calculator and you will get the answer. What is the answer? 28 over 28 plus 8 plus 32 plus 16 times 4 multiply by 100, which will give us 21.2%. 21.2%. Copper is element 29 in the periodic table. Brass contains copper. Brass is an alloy, we know. As you're reading through the stem of the question, you start to accumulate the information you have while studying your course, while studying your syllabus. So name the other metal in brass. We know what is it? Iron. State the term given to a mixture of a metal with another element. Alloy. They can ask you the definition of an alloy. What is an alloy? In the same way, so this is the definition which you have to write then. Copper can be stretched into wires. Copper wires conduct electricity. Name the property of metals which means that they can be stretched into wires. Ductile is the name we give to metals because they can be made into wires. The property is ductility. Like electrical conductivity is a property and metals conduct the electricity. Name the particles responsible for the conduction of electricity in solid copper. We know electrons. There are two substances responsible for electrical conduction. Number one, free electrons or delocalized electrons, better to write, in metals, and free ions in ionic compounds. When they are dissolved in solutions, the positive and negative separate, so electricity can flow, or better to say that these ions can move, causing electrical conduction. Next, copper is a transition element. Some physical and chemical properties of transition elements are shown. Physical properties: high density, high strength. Chemical properties: form colored compounds, have ions with variable oxidation numbers. State one other physical property of transition elements. So for this reason, you have to have at least 3 properties memorized or remembered, because when they give you these two, they are asking you for one another, not from this. So high melting point. Recall. This is simply recall. State one other chemical property of transition elements. This is entirely from the periodic table, in which you have to study the various groups and their properties. State one other chemical property of transition elements. They can act as catalysts. This is related to the chemical composition, the number of electrons, the number of protons. That's why we have this as chemical property, this as a chemical properties. But this is related to the bonding or the structure of the metal, so a physical property. Hydrated copper to sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules present in hydrated crystals. So normally we have a solution in which there are substances dissolved, but this is hydrated crystals. When you look at them, they'll appear solid to you, but they have water absorbed in themselves, and the water we have in them, it is called water of crystallization. State the color of hydrated copper to sulfate crystals. Same topic is going on, periodic table. So copper to sulfate, all compounds of copper, all solutions of copper are blue. Copper itself is pink solid, but the solutions, the compounds are blue. As it is a transition element, so it forms a blue colored compound. Write the formula of hydrated copper to sulfate. Copper to sulfate we know is Cu has a 2 plus charge, SO4, the radical anion, has a 2 minus charge. When these cross multiply, they can cancel out, so giving us CuSO4. Now we have hydrated over here. Hydrated means there are water molecules present. Standard way of denoting them is like this. This dot indicates water of crystallization. In any question they can maybe ask you to write the number of moles of water molecules, but here they're only asking for the formula CuSO4 dot H2O. Next, copper to oxide is formed when copper to nitrate is heated. This type of reaction is what we call thermal decomposition. State the class of oxide to which copper to oxide belongs. State the class of oxide to which copper to oxide belongs. So it is a basic oxide, as all metal oxides, this is acid, bases and salts, all oxides, there are oxides, metallic oxides and non-metallic. All of these are acidic, all of these are basic, meaning they react with water to form what? Bases. For example, copper to oxide reacts with water to form copper hydroxide, or some are insoluble too, but majorly they form basic solutions when reacted with water. For example, NaO plus water equals to sodium hydroxide, which is a alkali, the base, and they form acid. For example, P5O10 or P2O4, any oxide of phosphorus. Phosphorus is a non-metal. Phosphorus oxides, when they react with water, they form H3PO3, which is an acid, or H3PO4. However, you don't have to remember all the details of the reactions. This is just an example. You just have to know that metallic oxide produce basic solutions when reacted with water, and non-metal oxides are acidic, meaning that they react with water to produce acidic solutions. State the meaning of the Roman numeral in the name of copper to oxide. We know this is an oxidation state. This is a self-created term, oxidation state. There is no oxidation state really in the compound or in the element. What really is present is the charge of a compound affected by the number of electrons. This is something else, oxidation state. Next, 0.0200 moles of copper nitrate is heated. 0.0200 moles. Calculate the mass of 0.02 moles of copper nitrate. So the formula linking moles, mass, and what else can we know over here apart from mass? The formula is Mr. We can know N is equals to M over Mr. This M is mass in grams, and this Mr is what we calculate from the compound's formula. We are given 0.02. We have to calculate mass. So if we multiply the number of moles with the Mr, we get the mass in grams. You just have to remember this formula, this equation, and you can manipulate it as you like depending on what they are asking. So the mass is 0.02 times what will be the Mr. The Mr will be, for copper the mass is 64 for copper, nitrogen is 14, so 64 plus 28, as there are two nitrogens, plus 16 into 6, as oxygen is 6 and it has a mass of 16. 3 to the 6 oxygens. 0.02 times entirely this. So 64 plus 28 plus 16 times 6, 188. When we multiply this by 0.02, we get 3.76. Calculate the total volume of gas. Remember to read the words they have highlighted in bold and consider them in your answer. Calculate the total volume of gas in dm cube produced when 0.02 moles of copper nitrate is heated. Now this is concerned with the equation they gave us above, where they gave us this equation, because we have the ratio over here, the stoichiometric constant, the stoichiometric ratios over here. So calculate the total volume of gas in dm cube at room temperature produced when 0.02 moles of copper nitrate is heated. What will be the thought process over here? The thought process is that we know this is concerning moles, and the formula linking moles with volume of gas in dm cube, we know what it is. Number of moles equals to volume over 24 dm cube. This is also written in the periodic table. The number of moles, if we find out the number of moles, we can find out what? The volume. But total volume of gas, how many gases are being produced? We can see 2 gases are being produced. So total moles means the moles of this gas plus the moles of this gas. Total volume by these 5 moles. So we know the ratio is copper nitrate ratio gas moles. So when copper is 2, according to the balanced equation, the gas moles are 5. 4 plus 1, 5. 4 for nitrogen dioxide and 1 for oxygen. Now how many moles of copper nitrate do we have? 0.02. And how many moles of gas? We don't know. X. Cross multiply. X equals to 5 times 0.02, and when X is multiplied by 2, the 2 goes over to that side, divided by 2. This is 0.05. The answer will already be in DMQ. Next, powdered aluminum reduces copper to oxide. Write the simple equation for this reaction. Now reducing means whether you are decreasing the oxidation number of a compound of an element, whether you are removing an oxygen from the element. For example, if there is NaO, sodium oxide, and for some reason for any reaction, what I do is I separate the oxygen from it and give the oxygen to another element, lithium oxide. What will happen is this Na is reduced as the oxygen is gone away from it, and vice versa is oxidization. When oxygen is added to an atom, that is, the atom is being oxidized. So aluminum reduces copper to oxide, which means aluminum reacts with copper to oxide. Formula CuO, as Cu is 2 plus, oxygen is 2 minus, cross multiply, cancel, equals to CuO. The oxygen is being displaced by Al, as aluminum is higher in the reactivity series as compared to copper. This will be Al2O3 plus Cu. Al2O3, how did we get it? Because 3 minus charge on Al, O has a 2 minus, cross multiply, Al2O3. For the balancing, we know here are 3 oxygens, 3 copper, 2 aluminum over here on the right side, 2 aluminum on the left side, balanced. Now notice one thing, the copper is reduced as the oxygen is removed. What happens to the aluminum? The aluminum is oxidized as it has gained the oxygen atom. So it is a reducing agent, as itself it has been oxidized. Next, the organic portion starts from here. Propane, propan-1-ol and propanoic acid are members of different homologous series. Now we know the homologous series, we have 5 in our syllabus: alkane, alkene, carboxylic acids and alcohols. The homologous series have a same functional group, similar chemical properties. There is a specific trend of the melting and boiling point across them. Each member varies by a CH2 unit, and these are some of the features of a homologous series. Explain why members of a homologous series have similar chemical properties. and all of these contain 3 carbon atoms as prop, prop, prop. Explain why members of homologous series have similar chemical properties as they have the same functional group. The functional group is basically the identity card of the homologous series. Propane, it has propene, for example, alkenes are a homologous series having functional group C double bond C, carbon carbon double bond. Alcohol has OH as its functional group. Propanoic acid has COOH as its functional group. So this functional group is what really affects the chemical properties. That's why when in a homologous series of alcohol, all of them have this OH, so their chemical properties will also be the same. Name the homologous series to which propanoic acid belongs. Acid, propanoic, carboxylic acid. Recall. State the general formula of the homologous series to which propanoic acid belongs. So the series will follow a general formula in which you can estimate or you can deduce the formula by referring to the number of carbon atoms. For example, if I tell you what is the formula of propanoic acid, if there is a general formula, you can easily deduce the formula. Prop means 3 carbon atoms. So 1 is the functional group which is always present in a carboxylic acid, and the alkyl group is attached over here. Don't be confused with the name alkyl, it just means CnH2n plus 1. So over here the C will be CnH2n plus 1. How will we deduce the propanoic acid from this? Now we know this will be 2 and this H will be 5. So total 3 carbon atoms for propanoic acid, and this will be the formula for propanoic acid. How did we get this H5? Is because of this general formula. Whichever number is here, what we have is 2 times that number and add 1. So the general formula is CnH2n plus 1 COOH. CnH2n plus 1 OH. This is for alcohols. Propan-1-ol has an unbranched isomer. Name this isomer. So the isomers are just the compounds. They can ask you this in the question, what are isomers, or the definition, or give you 2 sets of compounds and ask you why are these isomers. So isomers are the compounds having same molecular formula and different structural formula. The arrangement of the arrangement of atoms is basically different. Otherwise, the molecular formula is the same. So, propanol, when we draw the structure of propanol, we know it has 3 carbon atoms, and 1 indicates that the OH is on the first carbon. H. This is the displayed formula of propan-1-ol. Now in alcohols, we don't normally study branching alcohols at this level. The one thing we do study is the position of this functional group. As the position of this functional group changes, the name also changes. For example, if we draw OH over here, and remove the O from here, this will now be propan-2-ol, which we required over here. Now we have named it. They have asked us the formula for this isomer. I already told you it will be this, having the OH on the second carbon. Pretty easy. They will, for 2 marks, they will check the position of OH and all the other bonds are connected correctly. Next, propane and propene can be manufactured by heating decane in the presence of a catalyst. One other product is formed. This is the product we don't know the formula of. Now what is this reaction? This reaction is cracking, in which longer chain alkanes are broken down into simpler alkenes and alkanes. They can ask you why this happens. Is because The shorter chain molecules burn better and they are high in demand in the automotive industry as they are used as fuels. So this process is cracking. What is produced definitely is propane and propene. The formula for propane is C3H8. The general formula being CnH2n plus 1. 2n plus 2, sorry. So whatever here, we double that and add 2 in it. So 3 2s are 6, 3 times 2 is 6, plus 2, 8. Plus propene. Propene is C3H6, as the general formula is CnH2n. Just double the n because there is a double bond present. Next, what will the third product be? Now we know that the total number of carbon were 10. 3 here, 3 here. Total number remains 4. 10 minus 3 plus 3. So we have something for 4 carbon and we can make an alkane CnH, applying the formula 4 times 2 plus 2, 10, C4H10. This is butane. Next, propene forms a polymer named polypropene. Draw the displayed formula of a section of polypropene showing 3 repeat units, meaning 3 areas where the same structure is present. Propene is normally this CH. This is a normal propene. When the isomer is formed, this double bond is broken. This is shifted or drawn over here as the stem continues from here. Let me show you the complete compound in this case. The C double bond C remains as it is. The C extends. The H remains. Another H is added. Not added. It was originally there. 1, 2, 3, 4 bonds of a carbon atom. So total 4 bonds of one carbon atom. 1, 2, 3, 4. The second carbon atom, the double bond is broken. It will have the original compounds over here, atoms over here, CH3, CH over here and CH3 over here, H over here and 1C and 3H over here. Now this will continue on because this is a monomer. Many of these molecules join together to form a large polymer containing thousands of compounds, thousands of propenes. This is joined. So what we have to do is we draw a propene once again. This is the propene we drew. Now we connect another propene to it. CH, CH, CH3. What will happen next? Because these are 2 repeat units. 1, 2. 3 repeat units. The third one here. The same compound will be drawn. Just you have to figure out this one bit. CH, CH3. This will extend till further notice because there are so many propenes joined together, we cannot form this. State the type of polymerization that occurs when propene forms polypropene. This is addition, in which a double bond of a carbon is broken and no other product is formed apart from the polymer. The second type we have is condensation polymerization, in which a small product is produced like water, but in addition no double bond. There is a double bond broken and no additional product is formed. Propanoic acid reacts with aqueous sodium carbonate to form a salt. The sodium carbonate reacts with propanoic acid. Propanoic acid is CH3, C2H5COOH, like we wrote above. When it reacts, the hydrogen is taken away from it by the sodium carbonate and the sodium forms a salt with the propanoic acid. The C2H5COOH, the H goes, the N comes, the Na comes because of sodium. The H goes, the Na comes. This will be C2H5 COO Na. Suggest the formula of the anion. The anion is the propanoate ion C2H5COO. Here we have to write the name. The salt is sodium propanoate. Similarly, if this would have been butanoic acid containing 4 carbon, this would have been sodium butanoate. You can see the pattern, right? Pentanoate, hexanoate, same thing. Propanoic acid forms an ester. Ester is when an alcohol and a carboxylic acid react in the presence of a catalyst. The catalyst is just all the organic reactions, whether it be the hydrogenation of alkenes, whether it be the addition of steam to ethene or any alkene. All reactions you have to memorize and have on your fingertips, the structures, the reaction requirements, the catalyst. In this case, when an ester is formed, the catalyst is H3PO4 concentrated, the sulfuric acid. The ester formed. Now this is another thing, the formula of an ester and the ester naming. First, I will try to explain you the formula, displayed formula. Propanoic acid, we know if we draw the structures, propanoic acid is CCCH OH. There is a double bond with one O and OH with another. This reacts with what? With an alcohol. With which alcohol? Ethanol, meaning 2 carbon atoms and the hydrogen atoms and the functional group OH. What happens when an ester is formed? This OH and this O, sorry, my bad, this HO. So what goes away is this OH and H combine to form H2O, and this leaves the molecule, and this oxygen joins to this carbon, and an entire molecule is formed. Let me show you. This will leave, and what will be formed is, see, I'm drawing the acid part containing the carbon oxygen double bond. This is the identification for the carboxylic acid part. CHHHHO. Now this OH is gone, this OH and this H is gone, so this will give you this O. Now it had one hydrogen attached to it. When that hydrogen is gone, it has free bond, it can make another bond with the carbon, so it makes it, and the original bond remains. And I will draw this with the red. Here you have it, the double bond containing acid part, propanoate and ethyl. This is ethyl. I missed a hydrogen. This is an ethyl because it contains 2 carbon atoms. Whichever alcohol we use, depending on the name, whether it is ethanol, then it will become ethyl. If it is butanol, it will become butyl, depending on the number of carbon atoms. And while naming the ester, we write the name of the alcohol first, ethyl, and how many carbon did we have here? 3, propanoate for the acid part. While drawing the structure, it doesn't matter which you draw first, but while naming, this is the standard way of naming it. Name the ester formed, ethyl propanoate. If they don't ask you for the structure, you can draw it for being sure, but just by saying the name of the acid. For example, if it is hexanoic acid plus propanol, you know that propanol becomes propyl and hexanoic acid becomes hexanoate. Okay, now we have reached the end of the paper. Thank you so much.